Yes. So let's begin with this numerical number third. We are seeing the velocity and acceleration by relative method. By relative method. We are in the third problem. This is with the sixth link. This is with the sixth link. Already we have solved the numerical of single slider crank mechanism. Only further two links they are added and made this as a six link mechanism. Six link mechanism. So how to draw the space diagram? Always you have to start with the space diagram. You have to write the space diagram. Now after seeing this numerical, you have to observe the dimension. What is the minimum dimension of the link and what is the maximum dimension? If you go through this dimension, A is 300, that looks minimum and maximum is 1200. By knowing the minimum and maximum dimension of your linkages, you have to select a suitable scale. Why suitable? Your figure should not, your space diagram should not be so small or it should not be so large. It should be appropriate one. That's why we have to see the minimum and maximum dimension. Depends upon that, you have to select your appropriate scale of the space diagram. Got it? So what scale you will suggest to select? 150, 100 mm, right? 100 mm is the scale for the space diagram. Now where to begin to draw the space diagram? Space diagram कहाँ से निकालना है? Always start with the locating the fixed point. Which one is the fixed point? O. They have not shown O is the fix, but it is fixed because O is the crank. O is the crank. So begin with the O. This is the locating the O. Draw one horizontal line here. I have located the O. Now using your scale, what angle made by the crank? 30 degree. You have to measure the 30 degree angle from this O in this direction. 30 degree angle. At 30 degree, you have to draw one faint line. You have to draw one faint line. Immediately mark here 30 degree. Now I know the length of the OA, crank OA. Crank OA is 300 mm. As per my scale, it is 3 centimeter. Right now, take the distance of 3 centimeter in your compass. Keep the compass here. Cut this faint line. You will get the A point. You will get the A point. Further portion of this line is not necessary. So whatever the faint line you drawn, make it dark. That is the OA crank. Over. Next, AB. How much AB is? 1200. 1200 as per the scale. How much it will? 12 centimeter. Take the 12 centimeter distance in your compass and keep the compass at A and cut this horizontal line. It will cut here. So that point will be the what? B point. That point will be the B point. I got the B point. Join A with the B. Join A with the B. So we got the crank. We got the crank AB, right? Any doubt up to this? Doubt है किसी को? नहीं. Then I have to locate the C point. Before that, one vertical slider is there. One vertical slider is there. Now the axis of this slider and axis of O point means between two vertical lines. They have mentioned that horizontal distance, that is 1050. So from the vertical line of this O, you have to measure the horizontal distance of 1050, horizontal distance of 1050, as per your scale it is 10.5. Measure the 10.5 horizontally. Let's consider that 10.5 is coming here. So this is the 10.5 centimeter as per your scale, but originally it is 1050 mm. So I got this vertical line. After getting this, you have to mark the C point. Where is the C? BC equal to B to C. BC equal to how much? 450 mm. As per your scale, it is 4.5 centimeter. Keep the compass at B and cut the C point on the connecting rod. So I got the C point. Right? Now after locating the C point on the connecting rod AB, I know the dimension of CD link. How much CD is? Again 450 mm. As per your scale it is 4.5 centimeter. Take the 4.5 centimeter in compass, keep the compass at C and cut this vertical line. Are you getting? So I will get the D point. I will get the D point. In this way, your space diagram will get completed. Join this D with the C. This is the space diagram. Any doubt to draw the space diagram? Doubt है किसी को? So I will draw the velocity and acceleration diagram on this screen. Is it okay? So I need that diagram. So I will go to the where to begin. Already I told that after finishing the space diagram, always you have to perform one calculation to begin with the velocity polygon. What is the direction of rotation of this crank? Anti-clockwise. So it is anti-clockwise. What I said, to begin with the velocity polygon, you must know the direction of rotation of any one link, crank, first link, crank. Right? So direction of rotation of the first link is anti-clockwise direction. Other thing that you must know is the magnitude of that crank. Magnitude of that crank. They must be provided with RPM or omega, angular velocity of that particular link. What data they have provided? RPM? Omega directly. RPM of that crank NOA is given as how much? 20 RPM. If you know the RPM, omega equal to 2 pi n AA divided by 60, 2 multiplied by pi multiplied by RPM is 20 divided by 60. How much omega you are getting? 2.09 radian per second. This is the omega. But after getting omega, you must be able to calculate the linear velocity. Linear velocity is given by omega multiplied by radius of that link. So omega is 2.09 multiplied by what is the length of AO link? 0.3 meter. How much it is? 0.627 meter per second. This is the velocity of crank. What I said, to begin with the velocity polygon, you must know for your crank, you must know the direction, you must know the magnitude of that link. Or is that clear? Yes or no? Shall I move ahead? So to begin with velocity polygon, I will write here velocity polygon. I have to take the scale. Why to take scale? I have already explained that. Scale क्यों लेना है velocity polygon के लिए? Because the magnitude is in meter per second. I cannot draw the line of meter per second. I have to convert this meter per second into the centimeters. That's why I have to assume गावड़े scale लेना है. आपको scale लेना है. So what scale you will suggest for this velocity by seeing that value? 1 centimeter equal to how much? 0.1 meter per second. This is my scale for the velocity polygon. First step to draw the velocity diagram is you have to locate what? Fixed point. How you are locating the fixed point there? Fixed point you are locating by the single point, and that single point is you are calling as a pole. You are calling as a pole. What are the fixed point in your space diagram? O is the fixed point. O is the fixed point. So in this space, you have to locate your pole. Poles are the showing the fixed positions of your space diagram. Poles are showing the fixed positions of your space diagram. So in velocity, we are using the notation small p. Don't change the notations whatever you have used in the space diagram. So my fixed position is O, that I have shown by the single point that is called as a pole. Or yes or no? चलो आगे बढ़ते. Next, start with the link of which direction and magnitude of velocity is known. Which is that link? O is the link. उसका direction मुझे मालूम है, it is rotating anti-clockwise and magnitude is 0.627 meter per second. So I am beginning to draw the velocity polygon with the link number OA, link OA crank. This is the OA link. It is rotating anti-clockwise. Where will be the velocity vector goes? Downward, no? Always remember the velocity vector for all link except slider is a perpendicular line to that link. Is perpendicular line to that? Yes or no? So what is the velocity vector for OA? A perpendicular line. Where? Downward or upward? Downward. Why? It is rotating in anti-clockwise direction. Getting or not? But you have to draw that perpendicular line in that velocity polygon. To draw that velocity perpendicular line to OA, there you must know O or A should be available. Which is available? O is available. It is sure that you have to draw that perpendicular line from either of these 2 points should be available. एक पॉइंट अवेलेबल है, वहां से मुझे परपेंडिकुलर लाइन निकालना है. तो परपेंडिकुलर फॉर O is I am drawing from O of what length? Some question will get arise. निकाल I am drawing the perpendicular line, but of what length? ये क्वेश्चन आपके मन में आएगा. तो आपको डिसाइड करना है. OA का मैग्नीट्यूड मुझे मालूम है, आपने स्केल लिया है. इफ माय 1 सेंटीमीटर शोज द 0.1 मीटर पर सेकंड, व्हाट इज द सेंटीमीटर रिक्वायर्ड फॉर 0.627 मीटर पर सेकंड? 6.27 सेंटीमीटर आएगा ना? यस और नो? सो लिमिट योर परपेंडिकुलर लाइन टू OA at 6.27 centimeter, and this point will be A. This point will be A. This is the line perpendicular drawn to OA. Hope you are getting. Immediately, बाद में नहीं होता. Immediately you have to put the arrow. You have to write velocity of A. Velocity of A. Over. First vector is over. Next. What is next link? AB. This is the perpendicular vector to what? OA, no? Yes or no? Next link is what? AB. This is the AB link. How to draw the velocity vector for AB? Perpendicular line. Perpendicular line to AB. Yes or no? Yes. I have to draw this perpendicular line to AB there in velocity polygon. Ask the question to yourself, from where? इसको निकाल रहा मैं AB को. A नहीं तो B पॉइंट वहां पे अवेलेबल चाहिए. कौन है अवेलेबल? A है. इसका मतलब श्योर होगा कि A से मुझे ये परपेंडिकुलर लाइन निकालनी है यहाँ पे. आर यू गेटिंग और नॉट? यस. ये है ये. सो दिस लाइन विल बी वेरी फेंट. फेंट लाइन है. I cannot draw the faint line here, but you have to draw very faint line. आपको ही दिखनी चाहिए. It is not, I don't know where it will cut. That's why that line should be faint. After getting the intersecting point, we will make it dark. समझ रहे क्या नहीं? Yes. चलो AB हो गया. AB is over. AB का वेक्टर ओवर. But the location of B वेक्टर कहाँ पे कट हो रहा है वो मेरे पास नहीं है अभी. Which is the next link? Next link is what? Slider. Slider. What is next link? Slider. Slider का velocity, I told that slider, this slider is moving horizontally. Yes or no? Yes. What is the velocity vector for slider? The line parallel to the line of stroke of that slider. Line of stroke of slider is horizontal. From where you have to show that vector of the slider? From the pole. कहाँ से निकलना है? Pole से. Where is the pole here? O is the pole. So O से एक लाइन निकलेगा. स्लाइडर हॉरिजॉन्टल मूव हो रहा है, इसलिए हॉरिजॉन्टल लाइन निकलेगी. And that line will cut the previous vector line. Getting cut or not? Previous. So जहां पे कट हो रहा है, that point will be the B, small b. Immediately put the arrow that shows the velocity of B, slider की velocity. Both points A and B are movable points. One can show the arrow toward the A. He can write velocity of A with respect to B. The further portion of this line is not needed. Any doubt? Now, which is the next link? Which is the next link? CD. Which is the next link? CD. चलो CD का परपेंडिकुलर निकालो. CD को परपेंडिकुलर ऐसा होगा ना. बट नेक्स्ट क्वेश्चन, आई हैव टू ड्रॉ दैट परपेंडिकुलर फ्रॉम आइदर C और D शुड बी अवेलेबल. C इज अवेलेबल है या नहीं है? इसका मतलब लिंक के ऊपर C पॉइंट है, AB लिंक के ऊपर C पॉइंट है. दैट मस्ट बी लोकेटेड फर्स्ट. दैट मस्ट बी लोकेटेड फर्स्ट. उसको लोकेट करने के लिए मैंने आपको सिंपल बोला था, इसको फॉलो करो आप. ये फिगर इधर लिख रहा हूं मैं, स्मॉल BC डिवाइडेड बाय BA इक्वल टू कैपिटल BC डिवाइडेड बाय. कुछ लोग बोलेंगे मैं यहां से लिखता हूं स्मॉल AC डिवाइडेड बाय AB. स्मॉल इक्वल टू कैपिटल AC डिवाइडेड बाय कैपिटल AB. ऐसा भी लिख सकते हैं, लेकिन जिसने यहां से निकाला है उसको मार्क करते समय A से ही मार्क करना है. वहां पे जिसने B से निकाला है उसको B से ही मार्क करना है वो डिस्टेंस. गेटिंग और नॉट? सुन रहे कि नहीं? यस. सो BC डिवाइडेड बाय AB, BC डिवाइडेड बाय BA इक्वल टू BC डिवाइडेड बाय B. So I will get BC from here. This BC is they have given how much BC? 450 mm. Don't change any unit here. जो वैसे है वैसे ही रहने दो इस फॉर्मूला के अंदर. ये mm में है, BA कितना है? 1200 mm कैंसिल हो रहा है ना. मल्टीप्लाइड बाय दिस BA. Where you will get this BA? BA डिस्टेंस यहाँ पे मिलेगा ना आपको. इसमें मेजर करोगे, सेंटीमीटर में मेजर करोगे. आर गेटिंग? और उस सेंटीमीटर वाले डिस्टेंस को यहाँ पे रखोगे. जिसने सॉल्व किया वो बता सकते मुझे. 5.4 सेंटीमीटर मीन्स कितना आ रहा है? BC इक्वल टू 2.02 सेंटीमीटर आ रहा है. इसका मतलब B से C का डिस्टेंस, स्मॉल B से स्मॉल C का डिस्टेंस कहां पे? स्मॉल B और C वेक्टर डायग्राम में. तो वहां पे मार्क करना है. मार्क करते समय आपकी गलती हो सकती है. वेयर इज द C पॉइंट? C पॉइंट ऑन विच लिंक? AB. वहां पे भी C पॉइंट मार्क करते समय आपको AB वेक्टर पे ही मार्क करना है. सुन रहे ना? AB वेक्टर पे ही मार्क करना है. बट आई हैव कैलकुलेटेड द डिस्टेंस BC मींस B से लेके C का डिस्टेंस मैंने कैलकुलेट किया है. आई गॉट दिस C पॉइंट. B से लेके C का डिस्टेंस कितना है? 2.02. दैट आई हैव मार्क दिया. गॉट इट? बहुत आगे चलो आगे बढ़ो. मुझे मिल गया C. नाउ यू आर फ्री टू ड्रॉ द परपेंडिकुलर टू लिंक. विच इज द नेक्स्ट लिंक? CD का वेलोसिटी वेक्टर कैसे रहेगा? A perpendicular line. A perpendicular line. From where you have to draw. Either C or D should be available. कौन available है? C is available. Now you are sure C available है, तो C से जाने वाली CD को perpendicular line दिखानी है मुझे. So I am drawing that faint line. Faint line है. Faint line. Getting or not? Yes. आपके इसमें faint line रहेगी वो. उसके बाद next link is what? Next link is what? Slider, vertical. How it is sliding? The line of stroke of this slider is vertical. So just you have to draw a vertical line from where it comes. Vertical line slider का वेलोसिटी दिखाने के लिए कहां से निकलेगा? O से निकलेगा. This is the O. O से एक वर्टिकल लाइन निकलेगा और वो लाइन प्रीवियस वेक्टर को कट कर रहा है यहाँ पे. दैट पॉइंट इज स्मॉल d. दिस वर्टिकल लाइन gives you the velocity of slider d. This line gives you velocity of d with respect to c. Yes or no? फर्दर लाइन मेरे काम के लिए उसको मिटा देता हूं मैं. इधर डाउट है? बहुत जब डाउट है? Do you have doubt? To start with the acceleration polygon, what I said, you have to make one table. That table includes the length of each link in meter, right? Then velocity of all linkages in meter per second. There are two components of acceleration. First one is the radial, which is also called as centripetal component of acceleration, and it is given by velocity square of that particular link divided by length of that link. That is the radial or centripetal component of acceleration. And second component of acceleration is the tangential component, which is given by angular acceleration alpha multiplied by radius of that link. These are the columns of your table which needs to before your acceleration diagram. So this acceleration must be in meter per second square. Now what are the links? See the mechanism. First diagram, space diagram. First link is OA. Second link is AB. आप बोलेंगे सर AC को पकड़ू क्या मैं? नहीं ना, पूरी लिंक कौन सी मेरी AB है. C is the point on the link AB. छोड़ दो, सुन रहे ना? Then CD and last one is the slider D. दोनों स्लाइडर को इंक्लूड कर दिया मैंने. हॉरिजॉन्टल स्लाइडर भी है B और वर्टिकल स्लाइडर भी है B. यस और नो? सो व्हाट इज द लेंथ ऑफ लिंक OA? 0.3. व्हाट इज द लेंथ ऑफ दिस? 1.2. व्हाट इज द लेंथ ऑफ दिस? लेंथ ऑफ स्लाइडर डैश. स्लाइडर को लेंथ नहीं रहती है, डैश. Velocity of link OA we have calculated 0.627 meter per second. Now other velocity of AB you will get here. You have to just measure this AB, vector AB from the velocity polygon, multiply this vector with the scale, you will get the velocity of AB in meter per second. Getting or not? मुझे किसकी velocity चाहिए? AB की. यहाँ पे आओ वेलोसिटी पॉलीगॉन में, मेजर करो ये वेक्टर AB, मल्टीप्लाई विद द स्केल 0.1, you will get the velocity of AB. Getting or not? How much? 0.5. Very good. Then CD की वेलोसिटी चाहिए मुझे. Measure this CD, vector CD, multiply with the scale, you will get the velocity of CD. कितना आ रहा है? 0.35. Slider B की velocity, measure this OB, multiply with the scale, कितना 0.38. measure this vertical OD, slider D की velocity, OD measure करना है, multiply with the scale, कितना आता है 0.21. हाँ, थोड़ा इधर उधर होता है आपके निकालने के ऊपर. So these are the velocity values of each and every link from the velocity polygon. बेटी जाओ क्या आगे बढ़ो. Now what I say for the first link crank, if your crank is rotating with uniform or constant speed, it has only one component of acceleration, and that component of acceleration for crank is radial or centripetal. पहले लिंक के लिए कंडीशन हमेशा चेक करनी है. कुछ न्यूमेरिकल में आपको दिया भी नहीं जाएगा whether crank is rotating with constant or uniform speed. नहीं दिया तो they must provide the alpha for crank. They must provide the alpha नहीं दिया है और ये सेंटेंस भी नहीं दिया यूनिफॉर्म रोटेट में. You have to write one assumption, assuming crank is rotating with uniform speed, then start your acceleration polygon. Getting or not? सुन रहे कि नहीं? So here we are considering that crank is rotating with uniform speed. How many components of acceleration for the crank? One. What is that? Centripetal or radial component? Yes or no? So radial component of acceleration. So here how to find out radial component of OA? Velocity square divided by r. This square divided by this. कितना आता है? 1.28. Second 0.25. Third 0. Slider के लिए dash. Slider के लिए dash because slider don't have the length. है ना? स्लाइडर का वेलोसिटी, स्लाइडर का एक्सेलेरेशन उसको कंपोनेंट रहते हैं. स्लाइडर का एक्सेलेरेशन अगेन इट इज शोन द एक्सेलेरेशन कंपोनेंट ऑफ द स्लाइडर शोन अ लाइन पैरेलल टू द लाइन ऑफ स्ट्रोक ऑफ दैट स्लाइडर. वेलोसिटी में जैसे हॉरिजॉन्टल और वर्टिकल निकाले ना वैसे एक्सेलेरेशन में स्लाइडर का एक्सेलेरेशन दिखाएंगे. सुन रहे कि नहीं? ये होगा मेरा चार्ट. अभी पहले लिंक के लिए मैंने बोला था first link is crank is rotating with uniform speed, so you don't have what component? You don't have the tangential component. What about AB link? Question mark. I will get that component after the completion of my acceleration diagram. CD का tangential I will get after completion of acceleration diagram. इसको tangential नहीं रहता है dash. This is my complete chart. Now I am beginning with the acceleration diagram. कोई डाउट यहाँ पे? Any doubt? नो आए? एक टेबल लिख लिया आपने? लिख लिया क्या? मुझे लगने वाला है बाद में वैल्यू. लिख लिया ना आपने? चलो. Now you have acceleration table, acceleration value table with you. Yes or no? By seeing the minimum and maximum acceleration value in that table, by seeing the minimum and maximum acceleration value in that table, you have to select a appropriate scale of acceleration. So my scale for acceleration diagram is 1 centimeter equal to कितना लो? 0.25 meter per second square. This will be the scale. How I have selected? By observing the previous table of the acceleration table. Yes or no? So I have selected the acceleration diagram polygon scale. First step in acceleration diagram, you have to begin with the locating the pole. Locating the pole. What are the poles? Poles are showing the fixed position of your space diagram. What is the fixed position of space diagram? O. So locate the O here. O dash. Here you have to use the notation dash. I have located the pole. Now come to your first link. You are about to draw the acceleration for the link OA. How many components of acceleration for OA? Only one. Which is that? Radial. Which is the center of OA? O. So my arrow moves toward the center. Now after imagining that arrow is going toward the center, you have to read it. The acceleration component is going down. Acceleration component is OA का acceleration कहाँ पे लग रहा है? डाउन. सुन रहे कि नहीं? O की तरफ मत पढ़ो. O की तरफ बोले तो आपको यहां से वेक्टर आएगा ऐसा. O की तरफ तो गलत हो जाएगा. Acceleration component is going down. Now I have to draw that acceleration component. Radial component always drawn parallel to this link, particular that link. Yes or no? From where I have to draw the radial component of OA. Either O or A should be available. कौन available है? O. इसका मतलब जो downward radial acceleration component है, that I have to draw a parallel line to OA from this O dash. Are you getting me or not? So I am drawing this line parallel with what? Parallel with OA in downward direction. And this component is the radial component of AO. और ये पॉइंट होगा मेरा A dash. Solid line in acceleration diagram always shows the net or resultant acceleration of that link. Solid line. मैंने solid निकाला नहीं. OA को एक ही component है and that radial component itself gives the resultant acceleration of OA. Getting or not? Any doubt? This line is drawn parallel to OA. Next link. Which is the next link? AB. AB का सेंटर कौन होगा? A. AB लिंक का सेंटर होगा प्रीवियस पॉइंट. which come first? A और B? A मेरा सेंटर होगा AB लिंक का. उसको दो कंपोनेंट रहेंगे. एक रहेगा रेडियल एक्ट ऑलवेज टुवर्ड द सेंटर. आपने बोला ये सेंटर है, एरो जा रहा है किधर? ए की ओर. लेकिन निकालते समय आपको क्या निकालना है? द रेडियल कंपोनेंट ऑफ ए बी विल बी गोइंग टुवर्ड्स right up. Yes or no? Getting or not? So from where you are going to draw, either A or B should be available. कौन available है? A available है. So I am drawing one parallel component to AB going right up. This is the dotted line parallel component to the AB. Why this side? Why not this side? This line is parallel to AB. Remember, सेंटर इधर जा रहा है. इसका एरो दिखाया ना मैंने. सेंट्रिपिटल कंपोनेंट ऑलवेज एक्ट टुवर्ड द सेंटर. ऑलवेज एक्ट टुवर्ड द सेंटर. Getting or not? किसी को डाउट है इसमें? Now second component of acceleration for the same AB. Another component of acceleration is tangential component. Another component of AB is tangential component. Tangential component is always perpendicular to the radial component. रेडियल जिस जगह पे है वहां से एक 90 डिग्री पे फ्रंट लाइन लगेगी, डॉटेड लाइन. ये पॉइंट होगा एक्स डैश. एक्स डैश से ये कौन सा कंपोनेंट है? रेडियल ऑफ AB. नाउ दिस इज द टेंजेंशियल कंपोनेंट ऑफ परपेंडिकुलर है. आगे नहीं बड़ा टेंजेंशियल कंपोनेंट ऑफ AB. कहां तक कट होगा ये मुझे मालूम नहीं. रुक जाओ वहीं पे. नेक्स्ट, व्हाट इज नेक्स्ट लिंक? स्लाइडर. स्लाइडर का एक्सेलरेशन. हाउ स्लाइडर इज मूविंग? हॉरिजॉन्टल वे, नो? सो जस्ट ड्रॉ वन हॉरिजॉन्टल लाइन फ्रॉम द पोल to mention, to show the acceleration of slider. Where is the O? From O, one line will come that will cut the previous line. Yes or no? That is the acceleration of this point will be the B dash, and this is the acceleration of slider B. राइट। नाउ जो लाइन मैंने पहले निकाली थी विच शोज द टेंजेंशियल कंपोनेंट ऑफ ए बी, जो बड़ी लाइन है वो मेरे काम की नहीं है, इतना ही लगने वाला है। वेयर द radial component of acceleration start here, no? Where the tangential component ends here, no? Join this by the solid line, and this solid line shows net acceleration of, this is the tangential component of, what it or not? Yes or no? Yes. Now similarly, until unless you are not locating the C point which is on link AB, again you have to follow the same process. What? B dash C dash divided by B dash A dash equal to BC divided by B A। वेलोसिटी में जो फॉलो किया हमने, यहाँ पे सिर्फ डैश में आएगा, आपको क्या मिलेगा यहाँ पे? B डैश C डैश डिस्टेंस मिलेगा सेंटीमीटर में। B डैश C डैश मीन्स बी से सी का डिस्टेंस, ये मार्क किया मैंने, अभी कैलकुलेशन नहीं बता रहा हूं आपको करना ही है। बी से सी का डिस्टेंस मुझे यहाँ पे मिल जाए, ये मार्क कर दिया यहाँ पे सीधे, सुन रहे कि नहीं? नाउ इट इज इजी टास्क। व्हाट इज नेक्स्ट? व्हाट इज नेक्स्ट लिंक? CD. How many components of the acceleration for CD? 2. One is radial, which is center, C or D? C will be the center. Where arrow goes? Arrow कहाँ पे जा रहा है? Upward. Yes or no? Getting or not? So radial component of CD will go up. मैग्नीट्यूड उस टेबल में है, मैग्नीट्यूड टेबल में है। कहां से निकलेगा? C से निकलेगा। कहां से निकलेगा? ये पेंट लाइन, ये पेंट लाइन। This is the line parallel to what? CD. Now this CD got another component of acceleration. What is that? Tangential component. अभी ये CD tangential component, CD का मैग्नीट्यूड आपने फिक्स किया है, आप एक्चुअल निकाल लो डायग्राम, ये ऊपर आता है कि नीचे? किसका कंप्लीट है? ऊपर आ रहा है कि नीचे? ऊपर आ रहा है। सो दिस लाइन विल कम हियर, radial component. Now you have to draw what? Tangential component. You have to draw the tangential component of CD, no? So this is the tangential component. रुको, मुझे मालूम नहीं है कहां पे tangential कट होगा। What is last link? D. D का एक्सेलरेशन कहां से निकलेगा? कहां से निकलेगा? O से निकलेगा। कैसे जाएगा? वर्टिकल या हॉरिजॉन्टल? वर्टिकल। ये है वो से निकला, ऊपर के टेंजेंट लाइन को कट किया कि नहीं? सो दिस पॉइंट इज बी डैश। रेडियल यहां पे चालू हुआ, टेंजेंशियल यहां पे खत्म हुआ, जॉइन दिस बाय द सॉलिड लाइन। आर गेटिंग? समझ रहे कि नहीं? तो दिस इज माय एक्सेलरेशन डायग्राम। मेरी डायग्राम एग्जैक्ट नहीं आएगी, आई एम एक्सप्लेनिंग हियर, आई एम एक्सप्लेनिंग। एग्जैक्ट नहीं आएगी, आप जब निकालोगे तब एग्जैक्ट रहेगी। होप यू गॉट दिस। यस और नो? बंदा लगा।